the maintainer kind of stepped away and let their domain expire. And then someone purchased the domain, tied it to their email address, created a working email, restored the password for whatever NPM registry, and was able to upload a new version with malicious code. There is no solution. Literally, there is no solution. It's a people problem that if we declare that we can solve it with computer science, we lie to ourselves. And this is one of the reasons why all the dependency managers suck, because every developer of dependency management promises themselves and everybody else that they are going to solve those problems using computer science, and it's impossible. So if whoever tells you Percy is going to solve the problem of supply chain security, spit them in the face. They're lying.
This episode is brought to you by our friends at Square. Develop on the platform that sellers trust. Support Square sellers by building apps for today's business needs. As a Square app partner, you can reach millions of business owners searching for trusted software solutions. As a Square Solutions partner, you can get hired by sellers on the Square platform, find new clients, and build apps that meet their needs. Square loves developers. They work hard to enable you to launch fast with their developer tools. You get a full sandbox environment, an interactive API explorer, live event monitoring, backend SDKs for PHP, Ruby, Java, .NET, Python, and Node. You get secure payment SDKs for iOS, Android, React Native, and Flutter. You get it all. Learn more and get started at changelog.com/square. Again, changelog.com/square.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. Subscribe to the pod if you haven't yet. Head to gotime.fm for all the ways. And if you dig the show, please do tell your friends. That'd be pretty cool. Special thanks to our partners at Fastly for shipping all of our pods super fast to wherever you listen. Check them out at fastly.com. And to our friends at fly.io. Host your app servers close to your users. No ops required. Learn more at fly.io. Okay, here we go.
Good time of the day is my new favorite greeting, and anybody who is listening at any time of the day. And today we are here to talk about the dependency managers, and I am here with my co-host Johnny. Hi, Johnny.
Hello, how are you?
Good. How are you?
I am good, but I'm sure I'm not as tired as you must be. You just got done finishing hosting GopherCon EU. How did it go this year?
Wonderful.
Nice.
But I am tired, you're right. And we are here joined today by Baruch Sadogursky. Hi, Baruch. How are you doing?
Hello. I'm very excited to be on this podcast because it's an awesome podcast with awesome hosts. And I'm a little bit bummed I missed GopherCon EU this year, but we already made set up a date to be there next year, I hope.
Absolutely.
So yeah, thank you for having me. That's exciting.
For anybody who's listening later or just not watching the recording, Baruch wears a really cool t-shirt that says Yalla.
Yalla.
What does that mean?
For those who don't know, for this probably small part of the population, but for those who don't know, what is Yalla?
So the meaning of the word is let's go, because go time, go podcast and everything.
Nice.
But also it's the name of our conference, the conference that JFrog organizes, a community DevOps conference in Israel. So, yeah.
So Yalla is the name of the conference?
Yeah, Yalla DevOps, actually.
Yalla DevOps.
Mm-hmm.
Cool.
Which is a very cool name.
Now we are here to talk about dependency managers.
Yes.
And before we jump into that topic, Baruch, would you like to introduce yourself to the crowd?
Yes. So I hate dependency managers with passion for the last, I would say, at least 15 years. That's kind of the relevant context. I've been developer advocate with JFrog for, I think, 11 years by now. Before that, working as a Java developer, senior developer, whatever it was, architect. And so we started in a previous company, the consultancy company. We were mostly doing the build CI CD. There was no CD back then, but build and CI parts of a lot of projects, trying new techniques with builds and dependency managers to make it reliable. One of those tools was what later became JFrog Artifactory, and this is how we got into dependency managers in general and JFrog in particular, and the rest is history. My dream is to eventually sit down and write a talk about how terrible every dependency manager on the surface of Earth is.
Okay.
I am looking forward to that talk. Please tell me what conference I will join.
Yep, that will be everywhere. Once I write it, I will go and preach about how terrible they are to everybody. And the most annoying thing is there is no solution really. And we can talk about that, why it is the issue we can talk about later. And by the way, Johnny, thank you for wearing this t-shirt. I love it.
Yeah, that's actually a JFrog.
Yeah, it's the frog and the gopher.
That is completely coincidental. That was not planned at all.
Okay.
It really wasn't, yeah.
It's just because the t-shirts are indeed cool every year.
It's very true. They are.
I am interested in sort of, obviously this is a sort of space you're very familiar with. I come from basically a long history of using various dependency managers for various languages. And yeah, none of them are really perfect, nor do I ever expect them to be, right? But each one has different pain points. Each one has things they do well and some things they could certainly improve in. But I'm curious, because you have sort of that broad view of a lot of them, right? What have you seen that sort of is the common thing that they all don't get quite right?
Right. I will quote Sam Boyer a lot, and you obviously know Sam. I hope you hosted him on your podcast, and if you didn't, you should.
No, we have.
And if you did, you should do it again. Sam is amazing, and basically he summarized all the problems with the dependency management perfectly when he said that dependency management look like a computing problem, and we try to solve it as a computing problem, but it's actually people problem. Like, it's the biggest problem with dependency management. There is no way to solve it just using the math, the algorithm, the computer science, because it always clashes with how humans behave. Your expectations, what do you do, how do you do it? And by that, the simplest example will be, you know what, stuff like backwards compatibility, binary compatibility. And you say, well, that's a solved problem. We have semantic versioning that solves it. It has guarantees which levels of versioning should work with others. And you say, well, it's a major version. It will break backwards compatibility. But if it's a patch, it shouldn't. Right? And then you code it in a way that your dependency manager will know how to look for a new version or not look for a new version, etc. But then it actually breaks very quickly when those guarantees are not fulfilled by the people who apply the versioning to their tools. And this will always be something that is human driven. People will decide which compatibility their software breaks or not, and they will make mistakes. But when you look at the algorithm side of things, it doesn't know about those mistakes, right? So you say, well, I can always rely on the fact that a patch level upgrade will work great because of backwards compatibility, but it's not, because someone made a mistake, right? There is no way to promise binary compatibility without relying on people's opinions on whether their software is compatible or not. Does it make sense?
Right, yeah, that totally makes sense. I mean, I can certainly see, for those who are not super familiar with sort of semantic versioning and how versioning is in theory supposed to happen, is that basically you're not supposed to be changing sort of existing APIs or imagine a particular method that does something. You're not supposed to all of a sudden change the signature of the function or the method, right, to accept new parameters or change existing parameters and then call it a patch, right? That's a breaking change. You are going to break other people's builds who rely on your dependency, right? So we're relying on individuals sort of do the right thing, but obviously for popular projects, even though it happens, these tend to be sort of mistakes. So really what we're saying is human mistakes. basically this is a sort of a gray area where algorithms can't really help you there, because it's a human making a decision saying, okay, I'm going to release this as a patch, but for some reason maybe they forgot, or maybe they not communicating with somebody else on the team or whatever it may be, and they accidentally release a breaking change as a patch when it's supposed to be a minor version bump or maybe a major version upgrade or whatever the case may be, right? My question to that is it really sort of a completely gray area that cannot be solved using basically an algorithm or using computers, right, to solve the problem? Like, do we not have tooling for that? Or maybe we haven't put in the time yet into solving to prevent these kind of problems. It sounds like we could create some tooling to say, hey, have function signatures change, for example, right? That way you have to have a different kind of a bump.
But that's the easy challenge, right? If you say like, just check that the signature is the same and the parameters didn't change and what's not, that's obviously doable. But how about the behavior, right? So in the end of the day, you made a patch and you made it for a reason, because you want the behavior to be different, right? But the question is if that's the right kind of different. Maybe there is a bug. Maybe it does now. You were supposed to fix the bug, but instead you introduced even larger bug. And now it does something terrible. In terms of the binary compatibility per se, your build won't break because the parameters are the same and everything. And unless you test for this behavior, you won't even know. And then you release it to production and then you discover it and now you need to roll back. Now rollback, it's another hell of its own, because now the behavior should change backwards and your software should actually be forward compatible in order to be able to work with part of the system will be new version and part will be in the older version. So it's really a problem that has no solution, because it actually depends on people always doing the right thing, which is not what's happening. But this is only one side of the problem. I can tell you another one, which is also very human-driven.
Let's hear it.
And that's the external dependencies, right? How do you get them where they are? How do you trust those who produce those dependencies, etc.? Right? So another quote, and I don't remember whom, I think it was Brad Fitzpatrick, that said that when you use external dependencies is like you just take someone else's random code from the internet and just dump it into your production systems. I think it was Brad. And he's on point on that. His solution was terrible, frankly, if you ask me. Before Go had Go modules, the idea was, hey, take their source and incorporate it in your source and then consider it your source, which is very, I would say, kind of an embedded word solution when you really do that and then you provide one binary. But for large scale systems that 80 to 90% of them are built with third-party dependencies, this is not a scalable solution in any way or form. So he pinpointed the problem correctly. It is a terrible idea to just grab other people's dependencies and throw them into your production system. But what is the answer? And we as an industry try to come up with the solution for many years now, and Go modules, the central repository, the signature server of the central repository, the earlier version of this vision when it was the idea of multiple central repositories that need to negotiate between them and establish some kind of a trust. Because if we have the same package under the same name come from different sources and their checksum is different, that means that someone is lying here and we need to find out who. This is another huge challenge, and especially today when we hear all those stories about how the supply chains of those dependencies got hacked, SolarWind for one example and multiple others. That's obviously the problem which surfaced lately but been with us for as long as we try and use dependency managers.
This episode is brought to you by Honeycomb. Find your most perplexing application issues. Honeycomb is a fast analysis tool that reveals the truth about every aspect of your application in production. Find out how users experience your code in complex and unpredictable environments, find patterns and outliers across billions of rows of data, and definitively solve your problems. And we use Honeycomb here at Changelog. That's why we welcome the opportunity to add them as one of our infrastructure partners. In particular, we use Honeycomb to track down CDN issues recently, which we talked about at length on the Kaizen edition of the Ship It podcast. So check that out. Here's the thing. Teams who don't use Honeycomb are forced to find the needle in the haystack. They scroll through endless dashboards playing whack-a-mole. They deal with alert floods, trying to guess which one matters. And they go from tool to tool to tool playing sleuth, trying to figure out how all the puzzle pieces fit together. It's this context switching and tool sprawl that are slowly killing teams' effectiveness and ultimately hindering their business. With Honeycomb, you get a fast, unified, and clear understanding of the one thing driving your business: production. With Honeycomb, you guess less and you know more. Join the swarm and try Honeycomb free today at honeycomb.io/changelog. Again, honeycomb.io/changelog.
So what would you say has been, like, I have some idea of how you'd go about trying to not solve, but really mitigate. But I want to hear what you've seen, right, in your experience of how people sort of mitigate that second class of problems.
There were and still are a lot of efforts in trying to do that. And it looks like, this is from our experience as well, we tried to come up with, again, back in a couple of years ago when Go modules only appeared, we heard this vision of, hey, we will have some kind of a network of central module registries that will communicate with each other, trying to establish this whatever truth really is and make sure that the rest of them are not allowed and everything. This is where we actually started Go Center, and that was one of those registries. But with time, in a matter of the next year, somehow this vision morphed to, hey, Google will maintain this central module repository, and whatever Google says is the right thing is the right thing. So this is where the need or the usability of Go modules kind of disappeared, because there was no more alternatives to whatever golden modules Google will give you. But that was a very useful experience for us to really try and evolve this idea of negotiating what's true is really took it forward. And I would say there are now two most important aspects of this system. The first is, how do we know which module is the right module? In terms of, hey, I have two of them, they named the same, they have the same version, but their checksum is different. Which one of them is lying and which one of them is authentic? That's the first one. And the second is chain of custody of those modules that we decided they are the right ones, right? So I decided that this module is authentic, and we can talk in a second why. And then we kind of, okay, how do I make sure that what I have now on my machine is really the same module, and the paper trail of the decision that it was the authentic model is actually preserved and cannot be hacked. That brought us to envisioning a system that everybody will be able to use in order to guarantee those two. And it's called Persia. And actually, Persia, that's an interesting story of the name. It's actually a system that the ancient Greeks used to convey messages with flames between each other. So this is why you have the torch. The idea is decentralized P2P network that will provide a consensus of what modules are authentic, and then make sure that they cannot be tampered with some kind of blockchain-backed ledger. I know that we lost 2/3 of the audience right now after I mentioned blockchain. But whoever stayed, you did the right thing. It has nothing to do with the cryptocurrency or Web 3.0. It's just untappable, a ledger that you cannot tamper with. That's the interesting part of it over there, right? So basically what we say is, okay, everybody now can build modules from source and publish them wherever they like. The system will communicate and decide if that's the golden build by comparing it to the build that the producer, the original producer of this module creates, right? So let's say I have a library now that I want to publish, and I create a build that, because it's my library, I know is the right build. Now everybody can have their own CI producing the same module from my sources, because my sources are obviously open source. As long as the build produced the same result, your end result is as good as mine. Now we record it, so no one can hack into that and pretend that other result is the right one. And then we distribute it through P2P network, because now we don't care where it comes from, as long as we can guarantee that it's the right results. So now Natalie builds it on her machine, and she's behind a firewall and the connection to whatever central repository is slow. But you sit the next door in the same intranet with her in the same company, and as long as we verify that the build that Natalie produced is as good as this golden one that was produced by the original maintainer of the library, you can use whatever she built without downloading it again outside of the firewall from and getting like tons of approvals and what's not. So this looks like, from our perspective, the solution or to some of the supply chain issues, because it guarantees the authenticity and it protects the supply chain itself, because we verify on your machine that the package you have is exactly the package you need to have, regardless of where it actually came from. And you also have this network of the Go registry, NPM registry, JFrog Artifactory, Maven Central, you name it, the sources that provide infrastructure for massive distribution and scale. And again, we don't need to trust them in terms of are they giving us the right packages, because we can verify by themselves. And also, in case of they are down, we can also rely on the P2P network to get the modules in case they are not available.
Does this approach require those who create those libraries, those dependencies, that they follow a similar set of sort of principles? Basically, I'm thinking of the recently sort of made public software bill of materials, right? The stuff that came out within the last year, right? For example, and basically that requires a specific set of things be present in order to know where did it come from, what's the version of each component, give me some identifiers, give me something that I can check against, right? Does that require, does such a system, a distributed peer-to-peer system, require sort of adherence to something like this?
Yeah, so this is the question of how we can verify that this golden module is really golden, it's really good, right? And this can be achieved in multiple ways. First of all, we can say, hey, let's say Go community trusts the Google registry to like a reasonable extent. And that means that if I produce a module for the Go community, I can delegate to Google registry to build my module and declare it golden, because I know that the Google Go module registry guarantees all those things and will make sure that my module is good. Since that point, it's all P2P with untempered ledger, and we're good to that. I can say, you know what? I don't trust anyone. I want to build it myself. The only binary that I'm ready to distribute or call it golden is the one that I built for myself. That's fine. Here you have, let's say, a PeerCA client that will take care of all the needed attestations, documentation, bill of materials, etc. And if you don't have them, then your build cannot be certified as this golden build that will be distributed to everybody or reproduced by whoever we want it to reproduce, as long as the checksums of both the data and metadata match. Does it make sense?
Yeah, it makes sense.
Right. So this is kind of our vision, and obviously it's just a patchwork of the problems that arose in the last years and the solutions that we saw working or not working. I can tell you example. So Maven Central, for example, been struggling with the problem of this authenticity forever, right? Because since they are existed from 2009. And they're like, okay, how do we guarantee that whoever publishes this artifact through Maven Central can actually do that? And they say, you know what? We're going to do PGP keys. So I need to have a key that I sign and uploading the public key with my artifacts. So when whoever downloads it can download the key and verify that I am the one that actually created it. Which sounds like a good idea, but you need to remember that the PGP idea was created to establish a trusted circle of people. It was created for email based on the assumption that everybody know everybody else through someone else in like whatever theory of 5 handshakes or whatever. So basically, if I send an email to you and that's our first correspondence, you don't know who am I, but Natalie knows who am I. She can propagate this knowledge to you. Now, it works in email, but for distributing binaries throughout the world, you have no idea who am I. So you downloaded my PGP key. It says Baruch Sadogursky, or it might say Brad Fitzpatrick. How do you know that I'm really whoever I claim I am? I can generate a pair of keys for any identity that I want. And if the only requirement of the central repository is to provide them with this key, I can be whoever I want. And the funny thing is, if you use the default PGP tool for generating keys for Ubuntu, at least that it was used to be, and then you just do like next, enter, the defaults are, I don't remember whom, some famous German, because the PGP key was created in some German university. I don't remember, maybe a writer. But anyway, it has some ridiculous default. Mozart, I think it's Mozart. Maybe it's Mozart, not German, but I don't remember, someone. But then you just take it and plug it into the search of Maven Central Repository, and you find hundreds of modules created by this person. Because most of the people, when they do tests, they just do next, and they generate a signature for this person and just upload it with their packages to Maven Central. It really doesn't verify the authenticity, right? And it's obviously not enough. On the other side, you don't really care. If I created a module, you don't care what my name is. And even if I'll tell you my real name, it probably won't help because you don't know me. What you need is to someone who you trust to vouch for this module. And this is where, when we have those golden registries or golden CI/CD pipelines that can guarantee that they took it from the right source, they have all the bill of materials, everything is safe, and then this is the outcome, this is the checksum of the data and the metadata, this is everything you need. And then you can decide whether you want to take this model from them, whether you want to build it from sources on your machine, and just compare that you have the same outcome. This is all you need. You really don't care what's the name of whoever built it. And this is why the PGP keys are not helping.
Okay, so in this new world, if I'm building software, I'm still, that first decision to use a dependency, right? I'm still making that choice, right? So if I go on GitHub, Bitbucket, wherever you, and I'm looking for a library that does X, then that job of identifying a library and deciding to trust it, right? Maybe I'll read through the source codes, making sure it's doing what it says it's doing, right? That first job, right, is not obviated by this new system.
And here we are back to the problems that cannot be solved by computer science. Mm-hmm. Right, and there are a bunch of them, right? We're just getting started. We work on a set of problems which is solvable. Those are the long-hanging fruits. How about the problem that the project is hijacked? You remember probably the story. There was a popular project that the maintainer kind of stepped away and let their domain expire. And then someone purchased the domain, tied it to their email address, obviously created a working email, restored the password for whatever NPM registry, and was able to upload a new version with malicious code. There is no solution. Literally, there is no solution. It's a people problem that if we declare that we can solve it with computer science, we lie to ourselves. And this is one of the reasons why all the dependency managers suck, because every developer of dependency management promises themselves and everybody else that they are going to solve those problems using computer science, and it's impossible. So if whoever tells you Percy is going to solve the problem of supply chain security, spit them in the face. They're lying.
We are go to ship in 3, 2, 1.
I'm Gerhard Lazu, host of Ship It, a show with weekly episodes about getting your best ideas into the world and seeing what happens. We talk about code, ops, infrastructure, and the people that make it happen, like charity majors from Honeycomb.
We act like great engineers make great teams, and it's exactly the opposite, in fact. It is great teams that make great engineers.
And Dave Farley, one of the founders of Continuous Delivery.
Start off assuming that we're wrong rather than assuming that we're right. Test our ideas, try and falsify our ideas. Those are better ways of doing work. And it doesn't really matter what work it is that you're doing. That stuff just works better.
We even experiment on our own open source podcasting platform so that you can see how we implement specific tools and services within changelog.com, what works and what fails.
It's like there's a brand new hammer and we grab hold of it and everyone gathers around, we put our hand out and we strike it right on our thumb. And then everybody knows that hammer really hurts when you strike it on your thumb. I'm glad those guys did it. I've learned something.
Instead, yeah.
I think that's a very interesting perspective, but I don't see that way.
Okay.
It's an amazing analogy, but I'm not sure that applies here. Listen to an episode that seems interesting or helpful, and if you like it, subscribe today. We'd love to have you with us.
So a question from the crowd, from the GoTime Slack channel. Somebody's asking that, or whether binary compatibility decisions are different among organizations. And Louis San Martin, who's writing this, is saying that at work they have the situation that they know what is a good code and reference a code and so on, so they don't reinvent those patterns every time. But for things like Terraform, he is not familiar with any. So would something like an RFC help to things like binary compatibility decisions and so on?
I'm not sure I understood, frankly.
If there is something like a good usage patterns and like good style and recommended whatever RFC equivalent will be for things like binary compatibility decisions specifically.
Yeah, so I think, again, if we look for standards, something codified, I would say that semantic versioning is actually a very, very good system to guarantee backwards compatibility, right? But again, with a twist, obviously, and the twist is humans. The idea is that, hey, we can rely on whatever version of patch version to be binary compatible, and minor version be API, public API compatible, and then minor not compatible to anything. And that actually should work for everything until we hit the problem that, hey, someone did incompatible things and called it a patch. Mm-hmm. And for that, frankly, I'm not aware of any possible solution at all. Unless I'm missing something obvious in the last 15 years, I don't see any way on how you can solve it. How you can prevent humans from breaking the guarantees that we build our machine systems upon. That episode, that's really sad. Sorry about that.
Maybe it will inspire somebody for something.
It's like everything, it sucks.
Yeah. Social engineering, but for packages.
I mean, social engineering is malicious, but even like honest mistakes, right? Let's not go and assume the worst, but even if we assume the best in people make mistakes, and there is no easy way to catch them always, and this is why we have bugs, and that's fine. But we have a system that envisions no bugs, and that cannot work.
So another point that came up on Slack by Henry Snupek is in the context of NPM registry compromise. So Henry is saying that vendoring could solve that
Yep.
to a point.
Yep.
If you require review checks before the dependency is being updated, or I guess it's a question.
So, two things here. First of all, let's talk about vendoring. Vendoring is the worst type of forking. You take someone else's code, you detach it from their version control, you dump it into your version control, and you're all for the races. You diverge from the original development. Bringing that back will be a terrible pain, and you basically treat it as your own source code when you cannot even determine what's your source code and what's not in machine reasonable way. The benefit of vendoring, and this is why Go relied on vendoring for a decade, is because it kind of ignores the supply chain problem. In a matter of fact, you say, I don't use any third-party dependencies at all. All the code is mine. I take full responsibility of whatever I'm using, whether I brought it through vendoring or wrote it myself. It's nice because it lets you ignore the supply chain problem, but it's terrible in any other possible way. So yes, it solves this particular problem, but the solution is usually more problems than actually benefits. And the fact that Go switched to Go modules from vendoring is, I think, kind of attest to the fact that vendoring is not a scalable solution. Vendoring is terrible in its own way, probably not the right solution for the supply chain problem, and we need to look for other solutions.
I would say my counterpoint to that would be, if what I care about, if I have a sort of a set of things that are important to me, right, for my builds, right, if reproducibility, right, of my builds, making sure I have the right version that I've vetted, that I know work with my stuff, right, I'm not worried about, a patch being incompatible, right, so I'd say this particular version, right, this particular commit, this particular cementing version, right, I know for a fact works to produce my piece of software that's working in my business that's supposed to be making money, right? If my primary concern is to make sure that I'm always able to reproduce that build with that same exact version of the code, then perhaps I don't care about the other factors, right? Perhaps vendoring works just fine because that is the first and foremost thing that I care about.
The good news are you definitely don't need vendoring for that, at all. Any modern package management today will give you full reproducible build by using dependency managers, because you have multiple layers of caching that you can lock what dependencies you use for this particular build without actually declaring third-party code as yours, right? And that's true for Go modules, obviously. It actually uses the directory formerly used for vendoring as a cache for modules now, and you have your own level of caching on your intranet, on your company or team level, being JFrog Artifactory or being it the Go registry, the local Go registry in this way or another. So you definitely can get repeatability. You definitely can reproduce the builds. You definitely can lock your versions that you are interested in after your vetting. Using modules or any dependency manager do not mean getting out there and grabbing the latest, the freshest dependency and dumping it in your build. No, it actually means doing the upgrades in the most convenient way on your terms. And your terms should differ based on your risk sensitivity in this particular scenario. If you just have a script that does something for testing or whatever, you can say, you know what, I don't care. I can download the latest version and just try to run with it. Worst case, it just fails. If you have a sensitive build, security, financials, you name it, then obviously it's a different game. You have a closed system that has to produce a reproducible build every time. The upgrades will be tested in multiple scenarios on different levels of testing, because before they will be allowed to be a part of your production system, and this is fine as well. But when you use a modular build system like Go modules, you can automate that and build a pipeline that will take a new version, not throwing it to production immediately in the next build, but getting it into this pipeline of verifications that can be completely automated, manual, half and half, whatever works for you, and only that propagated to be an official dependency, so you get all the benefits of vendoring without the downsides of declaring every third-party source code is yours.
Henry said thank you for your response, Baruch. And I am proposing we will jump to the fun part of the show of an unpopular opinion.
I actually think you should probably leave.
So I wonder if most of the thoughts you were sharing about will be ending up popular and unpopular, but I also wonder if you have an unpopular opinion for us that is on any topic if you want. Could be a dependency managers, could be anything else.
Yeah, we spoke for the last 45 minutes about that was one huge unpopular opinion. I will just summarize it to put it up to the vote. And dependency management was sent to us from hell to make our lives miserable.
All right. So any unpopular opinion goes through the vote on the Twitters. So we will soon find out what does the crowd think.
Okay, I'm going to turn on my Twitter bot farm right now. Because of my Twitter bot farm, that's why Elon Musk didn't buy Twitter. Because they didn't manage to find it yet. And they know there are a lot of bots there that know who own them, and that's me.
And you operate them all with DevOps.
Of course.
CI/CD pipeline for your bots.
Yeah. Built with another package manager that sent for us from hell to make us all miserable. Yep.
All right.
Cool.
I will say thank you very much to everybody who participated on Slack. It's fun when the crowd participates. And I will say, Baruch, very big thank you for joining and sharing your thoughts. That was definitely interesting to hear. Johnny, thank you for asking practically all the questions in this episode. You rock.
Yeah, I was definitely interested in some fresh thinking, and definitely called out a few of the pain points that I've definitely felt over the course of my career. And it's interesting to know that there's some new thinking being applied, right, to these problems. It doesn't solve all of our problems. There are some human aspects, as you mentioned, that are sort of unavoidable. Things like, basically how, the software bill of materials are leveraged, how we can sort of use a P2P network for authenticity and verifications and things like that. These are really some new things that are going to have hopefully some positive impact on this dependency problem from hell, as you say.
I really hope so. And we are learning and getting better step by step. But yeah, what we need to keep in mind that we cannot solve everything with computer science because humans.
Right.
Thank you everyone again for joining.
All right, that is go time for this week. If you haven't added Ship It to your weekly podcast rotation, you might want to reconsider. Gerhard recently had Gary Bernhardt on the show talking about the benefits of operational simplicity. Take a listen.
Most systems are far more operationally complex than what's needed. At least small to the bottom end of medium-sized systems. I have no opinion about large systems because I just don't work on them.
When you say operational complexity, what do you mean by that?
Everyone means something different when they say complexity, right? So let me say what I mean by operational complexity specifically. When we say that a function is complex, we mean that it has a complex structure, which is, there's no time element, right? It's complex now, and if we look at it a year later, it'll be equally complex. But when we say a production system is complex or a deployment is complex, that's operational complexity. It's about running it over time. It's about how it evolves and how it's maintained. So it's an active thing versus a passive thing. And I'm much more concerned about it and interested in operational complexity than I am about the static complexity of some code.
Continue listening and subscribe to Ship It at shipit.show/62. Thanks once again to our partners at Fastly for the super fast bandwidth, to Fly.io for serving up our changelog.com app, to the mysterious Breakmaster Cylinder for the dope beats, and to you for listening. We appreciate you. Next up on the pod, Angelica returns, and she's bringing some friends from the New York Times with her to discuss the art of the PR. Stay tuned. That's coming up next time on Go Time.